A bob is moving in a horizontal circle by means of a string with the initial speed of 10 rotation per minute. If the tension in a string becomes 4 times by keeping the radius constant, what will happen to the value of speed? It's known that the motion of a bob in a horizontal circle will be governed by the relation between centripetal force and the speed of a bob, whereas the centripetal force is provided by the tension in a string, and which can be written as an equation Fc is equal mv square divided by r. So here m is representing the mass, r is representing the radius, and v is representing the value of initial speed. Whereas the initial speed is given as 10 rpm rotation per minute. Here the question is, what will happen to the velocity when the force or the tension in a string becomes 4 times. So here we can write a new equation. 4Fc will be equal to m v nu square divided by r. So let us calculate the ratio now. 4Fc divided by Fc will be equal to m Vn square divided by r divided by mv square divided by r. When we are cancelling the similar terms, we will get the remaining term as 4 is equal Vn square divided by V square. We know the value of V, so we can write 4 is equal Vn square divided by 10 square. When we are simplifying this, we can write Vn square is equal 4 times 10 to the power 2. So Vn will be equal to 2 times 10, which is equal to 20 rotation per minute. So the new velocity will be 20 rpm, and the correct answer here will be option A.